We're going to go ahead and get started because I have a lot to talk about. I will start off with, this is the first of 2 sessions I'm doing on Python. This is the introduction session. So by introduction, I mean introduction. I'll show you how to get your environment set up and how the language works and everything like that. But then I definitely encourage you to stay through the whole summit. I think that's part of the reason why they put me at the end, because a lot of people wanted Python stuff. So I'll go into more advanced. We'll actually build a data model, and we'll score it, and we'll put it into Azure as a REST service and Flask, and actually see how to consume it. So we'll actually see kind of a whole way you could actually build an application, serve it out in Azure. That's what we'll do tomorrow at 3:30. Go home tonight, get your environment set up, learn what you learned today, and come back tomorrow, and we'll continue on from there. So I just want to plug my next session that's on 3:30, just because it's a continuation of this one. And I think you'll enjoy that one, because we'll actually have a lot of fun in that one as well. So hopefully you're in the right place. Came to learn some Python, learn how it's used a little bit in the Microsoft stack. So let's have some fun. Silence your cell phones if you don't mind. It won't bother me, but it might bother people next to you. And then explore everything PASS has to offer. They've said this 100 times, and they have the slide in here. But do vote. You're all, if you either know it or not, you're all PASS members, because when you sign up for this conference, you got to sign up for PASS. And hopefully you should have all probably filled out your profile, and you can vote and vote for, look at your favorite candidates, and you get to vote for 3. So definitely do that before you leave this week. And on to the agenda. So that's what I look like in a cowboy hat, although that picture's kind of dark. That's what I look like at night when I'm here. During the day, I don't wear the cowboy hat, so that's where the stat cowboy. Just because, if I was sitting in front of you in a session, you'd be like, I can't see. So I don't feel like carrying my hat around. The only thing that really matters up there is on the bottom right, it says code. That's where I've posted all the code I'll show you today. I also posted a PDF of these slides. I blog, not a lot, but there it is there as well. If you want to look at some photos I take, I do semi-professional photography, done some stuff in Africa and in Cambodia. So if you want to see what my outside interests are, you can look there. And then at the bottom left, that's me on LinkedIn and on Twitter. So follow me on Twitter. And if you kind of say, hey, I was in your session, follow me on Twitter, I'll know who you are, so I'll follow you back. And that way, if you have questions, I can answer you. I'm happy to do that. I'm not a consultant, so you don't have to worry. I'm not going to charge you. But I have a real job, day job, 9 to 5. So I'll do what I can to help you and answer your questions. But there's a lot of you in here. So all of you coming in, we have lots of seats over here. We can get you over here, and we can normally distribute this and get a Gaussian distribution. So I'm a data scientist and data engineer for a large oil and gas company out of Houston. And I do a lot with Python, a lot with Azure, and building cloud architectures to support a lot of stuff we do in the data science space, both out on the edge and on premises with our data there. So that's enough about me. That's not what you came to hear. So what are we going to talk about today? I'll give you a little introduction to Python. I'll go into how do you get Python? How do you get the language itself? How do you install it and get started? What's the best distribution? The answer is already up there, Anaconda. And then I'll go into the basics of the language. So once I get you started on how to install it, what's a good environment to code in, what are my recommendations, show you how to use some of that, we'll then go into the basics of the Python language, how to do comments, how to do number strings, how to get in lists, dictionaries, tuples, pandas, go into control flows, packages, and how to handle those and functions. And then finally end with a little tour of how Python all flows into the Microsoft stack, and then we'll have demos as well as we go along. Even though it says demos at the end, there'll be some demos as we go through. They won't be all at the end. But just what you signed up for, hopefully. Like I said, it is introduction. I've done this talk before, and I've had comments like, well, it was a little too basic for me. I was hoping to get more. Well, it's in the title. It's introduction. Come tomorrow. If you want to get a little more deeper into it, we'll go deeper into the language and actually using it for data modeling and deploying it. So why Python? Well, it's according to IEE, it is the #1 programming language right now as of 2018. It surpassed R and I forget what the other one was. That used to be #1, Java or C#. But it's very, very popular. But it's also embedded in so much of what Microsoft and other company, any company, Azure, Google, is doing around machine learning, data science, data analytics. It is the number one language of choice for doing these machine learning, AI, analytics type operations. It's pretty easy to learn. Has some nuances around how the structure of the code looks at. We'll talk about that later. And it runs on anything. It runs in Raspberry Pi. So who was at the keynote yesterday, right? And he held up the Raspberry Pi, and he's like, hey, there's Python in here, and there's, SQL Server in here. And, so you can go and develop these Python models, deploy them as Onyx models onto that SQL Server, Azure SQL Server Edge, and actually run your analytics down out in actually where your data might live out in the field. Work in the oil and gas industry. We have hundreds of thousands of oil wells, lots of pipelines, lots of things. We have tons of data being created out in the field, and these are things we're looking at, is to actually take and put that data, put the analytics down there at the edge, actually where the devices are, because they're generating second data, sub-second data, millions of records a day. And so having a language like Python, having tools like Azure SQL Server Edge allows us to then put that at the edge. And it's an interpretive language, meaning you don't have to compile an exe. You can, by the way. We won't do that today, but you can. There's a package you can download if you're with Python, and it'll create an exe, which literally bundles up the whole entire Python environment and the Python code and everything, and you can run it like an exe. I have done that. But for the most part, most people aren't doing that. You're writing a Python script, and that Python script runs when you run it, right? It's not like C# or something where you have to necessarily compile it to an executable or to a DLL or something. So everyone on board, Python's easy to use. It's the number one language, and that's why this room's so big and so many of you are here. So let's get started, and we'll learn Python. So how do we get started? So the easiest thing to do is to get the language first, right? We have to get the language, and the easiest way to get the language and the most popular distribution out there is the Anaconda distribution of Python. If you installed SQL Server 2017 or higher, and you decide to put the machine learning services on it, and you pick Python, it installed Anaconda on your SQL Server database for you. But it is the most popular one that most people use. And to get to it, there's the link there. You can download it. There's a little note up there about Python 2.7. It's going away. I forget I think it's next year, or I forget when the actual it's no longer supported date is. But some people still need 2.7. You don't have to click and download 2.7. You can download the latest version that's out there, install it, and you can set up a 2.7 environment if you need that. I doubt you will, because you're in this session here. You can start with the 3.x's and go higher. So it's going to either probably be 3.6 or something higher is what you're going to start with. But you can install the latest version, which is 3.7, and you're able, through the Anaconda distribution, set what version of Python you need. Now, I use Miniconda, and it's same people, Anaconda, that Continuum IO that produces Anaconda. They produce a smaller package of Anaconda. So Anaconda is a pretty bloaty kind of package. It's like several gigs. They have one that's a few hundred megs, and it gets everything I need, which is basically the Python language and what we call the Conda packager to manage my Conda environments and manages the packages in my Python libraries. So I use Miniconda, and that's the link for that. And that's what I use. And I install the latest version of that, 64-bit Windows, because I have a Windows box. If you have Linux, Mac, they have versions of Miniconda for that. So you go there, and then you install Anaconda or Miniconda, your choice. And now you have a Python interpreter, and you have a package manager to manage setting up environments in Python and setting up and managing your packages. So that's the first step. So I'm not going to show you how to install it. Just click the link, hit insert, next, finish. Right? Just take the defaults. It'll work fine. Once you install Anaconda, the biggest thing you get with Anaconda or Miniconda, I'll just say Anaconda from now on, so I don't have to keep repeating Anaconda or Miniconda. Your choice what you pick. But the great thing you get with the Anaconda Miniconda distribution is Conda. So Conda is the package management system, and it's the environment management system. And what I mean by that is I can install different environments of Python. So I can have an environment of Python that's, say, version 3.6 that has these certain packages in them. then I can have an environment that's Python 3.7 that has these certain packages in there. And the reason we do this is when we start working in the data science world, depending on the packages you need to use for your project, you'll find they have certain dependencies. They might depend on this version of a package, this version of Python. And so typically when I work on a project in Python, I typically have an environment for that project. And that project's going to have the version of Python I need, and it's going to have the packages I need and the versions that I need. And so Conda gives me a very easy way to set up these environments. And really, all an environment is, when you set up in Conda, it's a folder that's inside that when you install Anaconda, it's a folder in there called env, and then it creates another folder in there, which is the name of the environment you set up, and it has the Python executable in there, it puts all the packages in there, and then if you create a new environment, it'll create another folder under that env. And I'm going to demo this, but that's what's happening with Conda. So I can create these environments, they're just separate folders that can have different versions of Pythons, different versions of packages. But also Conda can then also be used, once I set these environments, Conda has its own package manager to install packages. So we can install packages into these environments, and all packages are enhancements to the Python language, whether they be machine learning packages like TensorFlow or scikit-learn or SciPy, or whether they be packages like Pandas or NumPy for manipulating data. And we're going to go more into packages in a second, but Conda is the tool that's really good from Anaconda that allows us to manage our Python environments. So I have these slides up there. Don't worry about necessarily reading the text up there. They're for your reference, so when you download these PowerPoints, you have a nice little quick reference guide to see this. But basically, what I have up there is the commands if you needed to upgrade your Anaconda environment, how to set up a new Anaconda environment. I'm going to demo these, so you'll see me type all these commands in a second. Also, a little note about if you needed to set up a 2.7 environment, it's pretty simple. If you notice right here, my pointer doesn't seem to want to be working. I apologize. Right there, I have to be right next to my screen. See where it says Python equals 3.7 right there? If I zoom, zoom it won't work. But right there is the version of Python that I told this environment to be. So if you needed 2.7, you would just say Python equals 2.7. It's going to install all the executables and binaries you need to run a Python 2.7. You probably won't need that if you're in this session. It's going to be people who've been using it for a while that might have some weird package that only works in 2.7, or some project they inherited that was built 6 years ago on 2.7. But you have that ability to control the version. And then some examples of using Conda to install the packages. So basically, what you see up there is I created an environment, which is going to create a folder in my Conda install, in my Anaconda install. That's going to have that version of Python, and it's going to be called, in this case, Python 3.7, right? So there'll be a folder under env called Python 3.7, and it's going to have all the base packages for a Python environment. Then I went and said, hey, install, I can't move from my machine here, and my screen doesn't work, my little pointer doesn't work, it's mad at me. I thought it worked further. And then I went ahead and used the Conda to install some packages into that environment. So I have to activate it and install some packages. I'll demo this again so you can see it again, but effectively that's what this is doing. Creating a folder with the version of Python I need with that name, and then I'm activating it so I can use it, and then installing some packages into that environment. You can list the certain environments that you have. So once you create different environments, you can see which ones you have. Once you're in an environment, you can do Conda list to list the packages that are installed in that environment. And then if you need to update, if you need to remove an environment, that's how you would remove a particular environment. So if you don't need it anymore, and then if you need just to update a particular package, that's some commands. And these are just a sampling of the main commands that I use every day when I'm using Anaconda. And then here's a little quick cheat sheet link to go and download for Conda there. And then finally, one thing that's kind of cool that I've been doing a lot lately is what will happen is you'll set up an environment in Anaconda. And so it has this version of Python. It has all these packages installed into it. And you say, hey, I want to clone that environment to use for another project, because it's a good starting point. It has everything I need, but I want to install some more packages. Well, we can use this Conda env export command to export it to a YAML file. And then we can use the Conda env create, pass the file name, to then create a new environment that'll look exactly like that environment. So it's a real quick way. And what's good about this is, if you're building demos for people and you want them to be able to easily create the environment that has all the right packages they need into it so they can run your demos, I can create that Conda YAML file with that command And then you can just download it, run that conda env create to that file, give it the name you want for the environment, and it will recreate that environment exactly like how I had it for my demo. So I haven't put the YAML file up on the GitHub, but I just thought about that out loud. I was like, oh, I need to do that. So that way, when you go download my demo code, you can run this. Yes, sir?
I'm just curious, and maybe you don't know the answer to this, but in Azure Data Studio, they have Python notebooks. Do you know what version you use, or can you?
So his question is, in Azure Data Studio, you have these Python notebooks and what version it uses. I haven't used Azure Data Studio a lot. My guess is whatever version of Python you point it to for the environment, right? I'm pretty certain it's 100% that way. I haven't used Python notebooks in the Azure Data Studio. I've used Azure Data Studio. I tend to use my notebooks just in Jupyter, but it just depends, because I'm a more pure data scientist than a data engineer than a DBA these days. But I will say this, the Azure Data Studio is where Microsoft's going for do data, so I will be switching a lot more over to that in some ways, but I spend a lot of time in Visual Studio Code. But good question. But yeah, it's going to be whatever environment you point it to, right? Because it's not installing Python when you install Data Studio. It's giving you the ability to run those notebooks. You have to point it to an environment that can have that, right? And so one of the things I'll point out real quick, I'll go back, is this package right here, Jupyter. That's the package that the notebooks run. So when you hear about a Jupyter notebook, we'll talk about it in a second, that's the package you have to install to run those notebooks in Azure Data Studio to run Jupyter Notebooks. So we'll move on, because I'm going to talk about Jupyter Notebooks in a second, I think next, actually, after I demo Conda. So let me demo Conda, just so you can see how to create an environment, see how it works, and then we'll go into the IDEs and how we can control the language. So once you install Anaconda, it's going to create a folder, and I'm just going to speak from Windows terms because that's what I use mostly. It's going to create a folder called Anaconda 3, and it's going to have a Anaconda prompt. In the latest version, it has the PowerShell. You can use the PowerShell, Anaconda PowerShell prompt, or you can just use the regular command prompt. It's your choice. I've been using the PowerShell prompt, but it's up to you. And what I want to do is, when I create my environments, I want to run that elevated when I run that prompt. And so I'm going to come in here, and I'm going to right-click on here and say Run Administrator, like that. And that's going to just been right here, right? Everybody see that? And the reason I do that is because when it creates the environments, because the way Anaconda is installed, it gets installed in your C program data. And if you want to create your environments in that C program data, it needs to be run as administrator. And I only run my prompt as administrator when I'm creating environments. When I'm using the environments and whatnot, I don't necessarily have to run it as administrator. But typically when I'm in the command prompt, I'm using it to create environments, upgrade packages, and that's it. I'm not running my Python code in this environment. So you're typically going to run it in elevated or run it as administrator, so that works. So just for real quick, I'm going to do conda env list. And I think if I do this, let me do this real quick. Let me just bump that up a notch. Is that better? Can you see that in the back? We're good? One thing I forgot to check. Checked all the other fonts. So as you can see, when I did this conda env list, you notice what we see there, right? We see that we have the folders that they're in. This is the base one. Never work in the base. And if you notice right here where it says base, this is the base. This is just kind of the base install. When you set it up, you'll have one environment. It'll say base. Never use that environment. Always create new environments for working in your Python code. So how do I create a new environment? I say conda create -- name. We're at Summit, so I'll call it Summit 2019. And then I'm going to give it a version of Python. And I'll just pick 3.6, right? And we're all going to pray to the internet gods that the internet gods are working, although most of the packages I need should be already staged on this computer. And as you can see, it's going to install these base packages, like pip, Python, different things. It says, do you want to proceed? And I say yes. And it's extracting those Python packages, and it's going to set up this environment. And like I said, it's just a folder that has the Python exe, the DLLs, the packages that I need to work in my environment. Everybody with me there? and how that works. And if you think about it, when you're scripting, it's a folder. If you need to call Python and your script, you'd point to that environment that you need in that folder to call that Python exe, and then you know you're running that version of Python. So we're just going to wait a second for that to finish. Yes, sir. Question. Good point. Question.
What would be the reason for you not to use the latest and greatest? So latest and greatest, let's say it's 3.7.
Yeah. So his question is, why would I not use the latest and greatest? The latest and greatest, let's say, is 3.7, although I think 3.8 finally just came out like a month ago. The reason is because certain packages that you might need to use for your project don't support the latest and greatest. So a lot of things like, I think TensorFlow, I think it's up to 3.7. Most things are probably not at 3.8 yet, so you're not going to probably use 3.8. A lot of packages that you're going to use were developed on like 3.6, right? And so you needed to use 3.6. So that's when you start working on your projects, you kind of need to know, hey, these are the packages I'm going to use. What version of Python do they support? So you go to the web page for, say, gradient boosting or to scikit-learn, and you go and look and say, hey, how do I install that? What version of the Python do they say they support? And then you would set it up to that version. But good question. All right, so my environment's set up. Once it's set up, I need to activate it so that I can do things like install packages into it. And so the way I do that is I just say conda space activate space the name of the package, the name of the environment. Real quick, I'll do a conda env list just so you can see that now I have this Summit 2019, and this is the folder it's in. And if I copy that folder and get very brave and go to it, you can see what's in there, right? If you go and look, there's going to be down here at the bottom, Python exe, right? So you can see that's all I did is just created a folder that has that version of Python. If I go in the env here and I go look at Python, let's say 3.6, same thing, right? It looks very similar. But it also has all these other folders where it's going to put the packages you install in that environment and whatnot. So one thing to note, if you notice right here, notice I have a couple of them that are installed in C users jj.conda envs. What happened there was when I created those environments, I didn't run elevated. And since I didn't run an administrator, I can't install in the C program any Conda 3 envs. So it says, OK, I'll just install it into your local user home directory. And that's fine. It's up to you. And the reason you might do that both, to be honest with you, it doesn't really matter. I just prefer to run an administrator, have it all in C programs, mini Conda, because sometimes it's hard to forget that it's in C users jj.conda.env. And if I know it's always in C program data mini Conda 3, then I know where to go and look. If you install so remember, I stepped back for just a second, and I said you can install Anaconda or you can install mini Conda. If you decide to install the full version of Anaconda, your directory will be C program data Anaconda 3. So that's just a little caveat. So if you pick the full version of Anaconda, it will say Anaconda 3, not mini Conda 3. Quick question. Yeah. Yeah, so his question was the packages that got installed, there's like 6 or 7 that listed when I did the Conda create. That's by default. Those are the default. We have to have these to have Python and to have a Conda environment. So now I'm in this environment. Let me escape out of there. You see right here, it says Summit 2019. I'll scroll up a little. And if I want to install some packages in there, I can install, like, for example, Seaborn. It's a visualization package. But notice, it didn't just pick Seaborn, and then picked all these other ones. And notice how it said these will be downloaded and different things, right? So it has certain things. It checks all these dependencies. It can install Pandas. And so if I hit yes, it's going to go and install that package. So now we know how to set up an environment in Anaconda, or mini Conda, depending on which one you use. Now we have an environment that we can use to write code, right? So everybody with me? It's very important because when I first started on Python again, like 6, 7 years ago, and I did it like 20 years ago, you just you got Python and you ran it, right? And now we have all these environments and different things. It was hard to kind of piece together all this mini Conda, Anaconda, how do you manage your Conda environments? And I think it's very important because I get a lot of data scientists that come to the company where I work, and she can tell you because she works at my company, and they know nothing about this. All they know is they were given a computer in the lab when they were getting their PhD in deep learning, and it already had Python installed. And so, it's important to know how to do this. So I'm just going to let that run in the background because I don't really care. I already have an environment set up for the demos. But that's what I wanted to show you is how to manage that Conda environment. So, packages. You just saw me do this, right? I just installed, for example, the Seaborn package. There's 2 package managers if you use the Anaconda distribution. There's pip, which is the one that comes with Python by default, and that's that's the one that's recommended by Python for installing your packages. But if you're using Anaconda or Miniconda, use Conda. And the reason I say that is most of the standard packages are in that Conda distribution. It's going to make your job a lot easier. You just type Conda install, try to install the package you want. If it doesn't work, then I just do pip install the package I want. Now, I will caveat this. If you're installing things like TensorFlow or a package you're not familiar with, most of those things have websites. Go to their websites and say, how do I install your package? And just follow what they say. Because some of them will say install it for pip, and some of them will say, oh, if you're using the Anaconda distribution, use Conda, and this is how you use it. So follow the directions. Not all of us are good at following directions. Some of us just say Conda install, and we type a package, and it worked. And some of us then, if it didn't work, it says I didn't find the package, which means it's not in the Conda distribution. Then we type pip install a package, and it works. We're like, OK, it worked. But as with anything, if there's directions there, I recommend following them. But it makes sense. We have 2 package managers from installing packages into our Conda environments, which are our Python environments. And like I said, all a package is some extra functionality for Python. Somebody wrote a package called Pandas. We'll talk about it in a minute. They'll do data frames, which act like tables to do data manipulation or data. Somebody wrote a package called Jupyter, which allows us to use notebooks to write our code in. Somebody wrote, I say somebody, it's multiple people generally. Somebody wrote scikit-learn, which is a machine learning package that has all these machine learning algorithms like regression and random forest and decision trees and all these things, so that we can then use them to write code in our data to do machine learning, right? That's what packages are. Yes, sir.
So are we doing all these installs inside of Python, or are you doing this inside the command line?
So I'm doing all these packages. I'm installing it from that prompt. Now, I'll do the IDEs next. The IDEs have the ability to install the packages as well. You can do them through the IDEs as well. So if those who don't know what IDE is, it's an interactive development environment, I think is what IDE stands for. It's a GUI to write code instead of a command line or a text editor. But yeah, some of the IDEs will allow, like Pycharm, Visual Studio Code, which is what I use now, will allow you to install those packages. I typically just go to the command line and install them. And one of the main reasons is because I ran these as elevated to create my environments. So I need to be run as elevated to go install the packages. And you're not going to want to run Visual Studio Code elevated or Pycharm elevated. So we won't be able to probably install that packages. It can use the folders once you create them. But good question. But I typically install it from the prompt, the packages. So moving on, once I have packages installed, to use them in my code, I use these import statements. And you'll see this throughout the code. But I got a package installed. I want to use PyODBC. Who can guess what PyODBC does? ODBC, we can read databases, right? If I want to use Pandas, these are how I can import these packages. Import sys. Sys is a built-in package. I don't have to install that, but I can see what version of my Python is by doing that. Everybody with me? So we know how to create an environment. Remember, it's just a folder, has a version of Python, has my packages in it. We know how to install packages into my environment. I will show you one other thing real quick that I forgot to show you. One very important package, because I'm going to show you Visual Studio Code that I'll install, and that is Pylint. And this is on a slide in a second, but since I already had the prompt open, I wanted to show you that. And what Pylint does, it does syntax highlighting and syntax formatting and like, hey, this does not write code. And so always install Pylint into your environment. It'll help you out. And it's not like a package you'll import. It's just the tools will use them. So here's some popular packages. You heard me say these names, but Pandas, it's a data frame. We use it to bring, and it's not only does it support data frames and series to bring in data structures. And if you think, and a data frame, just think of like a table. It has columns and rows, and they have data types for those columns. That's what a data frame is in Pandas. But it also has tools to import data in through like CSVs, how to support ODBC. All that's built in that Pandas. PyODBC, exactly what it sounds like. Matplotlib, it's a 2D plotting library. It's built off of MATLAB. I mean, it's built to kind of mimic like what we do in MATLAB. Scikit-learn, it's just a machine learning and linear algebra, statistics type thing. Excuse me, not linear, that's NumPy. Excuse me, machine learning and data analysis and statistics. It's some of the base packages people use to do machine learning. And then we have NumPy, which is a dimensional n-dimensional array structure. So you can have 1D, 2D, 3D type data. So we do a lot of seismic interpretation where we're building seismic interpretation, and we can go out 3 and 4 and 5Ds worth of dimensions of data in NumPy to do that. So that's what NumPy does. And then SciPy is another mat stats type of thing. But these are just some of the popular ones you'll hear people talk about. Some of the ones you didn't see up there, like TensorFlow. You might have heard TensorFlow. You might have heard Keras. Those are very popular for deep learning. Microsoft CNTK, that's the deep learning packages and stuff that Microsoft has. And what deep learning is this is a cat. This is a chicken. Or, hey, I want to look at a bunch of text and calculate, what's going on there, what's sentiment, things. These are some of the things we do with deep learning type models, not modules, models. And using artificial neural nets, right? Trying to mimic what your brain does, right? When I look at this guy, I go, yeah, he's from New Orleans. I know because I can just see the look, right? But we train deep learning neural nets to do that, right? I know him. So he's a Saints fan. He's got a smile on his face because Drew Brees is healthy and back. So for all you people from not America, that's the football you throw with your hands and occasionally kick with your foot. Trust me, I'm a Chelsea fan. I like the football you kick with your foot more than the other kind. But those are packages we use in Python. Yeah, exactly. I was waiting for a Man U or what, Spurs? What are you? Man City, okay. City, yeah, I got you. All right, you can cheer for your favorite soccer team. We can have fun. It's after lunch. We got to stay awake, right? So those are some popular packages. I won't demo it because I just did, right? I showed you how to install them. Yes, sir.
So are you recommending installing those? And if so, do those take a lot of space?
So his question is, do you recommend installing those? Only if you need them, right? So, set up your environment like I just did. Don't install any packages other than Pylint and then until you know what you need. If you know you're going to run Jupyter Notebooks, then install Jupyter. So and we'll talk about what Jupyter Notebooks are in a second if you know what those are. Then you install Jupyter, but minimum set up Pylint so that you have the linear environment to get syntax highlighting and all that. And then depending on what your project is, right? If you're going to need Pandas to bring data in, and you're going to do scikit-learn to do some regression models or to do some random forest models, then you would install scikit-learn and probably Pandas and NumPy. Yes, sir. Yes, so his question is right here, as pSQL right there. That's an alias. And that keeps me from having to type pandas.io.sql. some function. So I can just say pSQL. some function. And you'll see, like, pandas, for example. You'll always see pandas, not like pandas IO-SQL here, but just import pandas. You'll always see, like, import pandas as PD. And then PD.this. And so this is very popular thing that people do. They don't always alias every packages, but the ones like pandas that have lots and lots of functions, they'll usually alias it so they can just say like pd.dataframe, pd.readcsv, things like that. Good question. I just demoed packages. That was that Conda install space something. Remember I did Jupyter, I think, or Seaborn, and I did Pylint. That's how we install packages. If the Conda install didn't work, try pip install, and it should probably work. So everybody's good. Yes, sir. So what's the difference between install and import? When I did the Conda install at the prompt, I'm actually installing the package so I can use it. What you're seeing in this right here, this is when I'm in the actual Python code, and I want to use, say, the PyODBC package. I have to type this command import PyODBC to bring that package in, because it's not native Python functionality. It's a package I've added to my environment so that I have this functionality. So what this is Python code. That Conda install is just a command. It's an executable on that prompt. Good question. Thank you. Yes, sir.
Is there an implication like if you import a lot of packages?
So his question is there an implication if you import a lot of packages and don't use them, they just take up a lot of space? And then when you come back tomorrow, we'll talk about how we're going to deploy these out in Azure and into containers and different things. And if you have 3 gigs of packages that you're only using one, 100 meg package, You don't want to deploy 3 gigs of packages in your container. It's a waste of space, right? And so, yeah, only use the packages you need in your project is what I recommend. Don't create a jumbo environment that has every package, and that's the only one you use for your projects, because I assure you down the road, when you start really building projects and using Python, you want to set up environments for each of those projects, because you really want to keep everything light and small and compact as you start deploying these to containers and to Azure serverless and to things like that. Does that make sense? It's a good question. It kind of goes back to the question you had earlier, like, about the space and all that. It's like, yeah. And you remember, each environment, this had Python exe. Each environment's going to have the packages you install, and some of them can be several gigs. So IDEs. So these are what we develop in. Pycharm is by far the most popular. It's the one that most people use. I used to use it a lot. Spider comes with the Anaconda distribution. I don't know many people that use it. I know a couple people. Not that it's necessarily bad, but Pycharm is the most popular. But the one that I love, and the one that I've been using, it's not because I just like Microsoft better. The one that I love and I've been using since January of this year, because the Python extension that came out in January for Visual Studio Code is Visual Studio Code, and it allows me to do Python interactive terminals in Visual Studio Code, which are really, really nice. So basically, it's using the Jupyter Notebooks behind the scenes to run my Python code, and it makes it for a very nice experience. And there's links to get information about that. I'm going to demo Visual Studio Code here in a minute. I won't demo the other ones for sake of time, but I do have some slides on there for those of you that say, my company uses Pycharm, so I have to use Pycharm. I do have some slides on there for some information for you. I think even in the GitHub, I have like a Pycharm shortcut cheat sheet, if I remember right, as well. But it is the most popular. I like Visual Studio Code. This is for the IDE. And one thing you're going to learn when you start developing Python, you're going to have people who use Pycharm, people who use Visual Studio Code, people who use Jupyter Notebooks. I'm going to get there. Jupyter Notebooks. You're going to have people who are like, I work in Databricks, and I use the Databricks workbook, because you can do Python there. We'll talk about that in a minute. But you're going to see multiple environments. You're going to figure out what you like and what you're working in. But when it comes to IDEs, the top one is the most popular, and the bottom one is my new favorite. And I've converted several of our data scientists. I'm slowly converting them all to the bottom one, because that's really nice, and it works really well. So I'm not just saying that because you're at a conference that Microsoft's the main sponsor. I promise you. So Visual Studio Code, some shortcuts. Command palette, Python interpreter. Don't worry about those two as much. I'll show you in a second how the extension makes it so you don't have to worry about that as much when you're dealing with Python. The Python install Pylint. You saw me install that, right? So when you're working with your Visual Studio Code, you're working in your Python environment, if you want that pretty highlight syntaxing where it makes different colors for different functions and it puts little squiggly lines where the code's not right, that's what Pylint gives you. The command that you need to know, the main thing is Shift-Enter. So if you're sitting on a line of code and you want to run that line of code, you hit Shift-Enter. Or if you highlight the lines and hit Shift-Enter, it'll run those lines you highlight. That's how you do it. If you used R, you may use R. If you use R, it's like Control-Enter in RStudio, except for unlike RStudio where it jumps to the next line. Or if you had if you were on a function, you hit Control-Enter and it'll run the whole function. It doesn't do that here. You have to highlight everything you need to run and hit Shift-Enter, and then you have to move the mouse to the next line. Important things to do if you're going to use Visual Studio Code, make sure you install the Python and the Anaconda extensions, because it's going to make managing your environments that you're coding in Visual Studio Code that much easier. And then the cool thing, and this is why I switched to Visual Studio Code, is this Ipython console support. So Ipython is what Jupyter used to be called, and then because it was just an interactive notebook to run Python in like a web browser. And then they expanded it to not only just run Python, it can run R and SQL and different things, and so they renamed it Jupyter. But it now allows for a really interactive experience, and I'll demo this and you'll see what I'm talking about. But this is why I really like how the code runs and works in Visual Studio. I just find it a lot easier to use. Can y'all hear me in the back? Good, okay. Sorry, my mouth is dry up here. Pycharm, there's just a reference for you guys if you want to use Pycharm. If you go to the things, they're there, but I still take pictures too, so I'm not making fun of you. I sit in sessions take pictures yeah, I know they're making fun of me because it's in the slide deck. But yeah, I take the ones that matter, right? You hit the little little heart next to it in your iPhone, so you know, hey, that's what I want to go back and remember. But yeah, all this is up there. It's in Jupyter Notebook. So the IDEs are your typical, like if you've used Visual Studio or, you know, or any kind of IDE, that's what the last slide was talking about, those type of IDEs. Jupyter Notebooks is a little different experience. It's a web, you actually develop the code in a web browser. And so it's running a server and behind the scenes on your computer, and it's serving on a web host for you, and you browse your folders, and you go create a Jupyter Notebook. It'll have an IPYNB extension, as in IPY Python NB notebook, so IPython notebook. That's the extension for Jupyter Notebook, and you write that code in the browser, and you can run it, and it's interactive, and you can see it. And the cool thing it supports, and why a lot of people like it, is it also supports markup really well, so you can have code blocks that are just markdown language, so it's like HTML, and then you can have code that's Python, and you have code that's Markdown, and you have code that's Python. Then you have another code block that might run SQL, because you can do that. But it has this nice interactive experience. And where I find this very useful is I tend to stand in Visual Studio to write my machine models or write my code, and then if I want to go explain it and show it to somebody, a lot of times I'll then move it into a Jupyter Notebook so that I can mark up, hey, this is where I got the data from. This is what I did to manipulate that data. You know, this is the models I picked and why I picked them. This is what here's the output, and this is what this output means, and this is what this score means, and this is what, you know, this interpretation means. And then I can go and tell a story. So researchers at universities love it. Or if you're going to put your code out there and demo it, you're going to see me demo it in a second in the Jupyter Notebook, because it's just easier to see than seeing it in a Visual Studio environment in the IDE. So this is kind of where you go. And I have people that code strictly in Jupyter Notebooks at my company. I have people who strictly code in IDEs, whether it be Pycharm. And then if you get to other things like Databricks and stuff, they're notebook-based as well. But it's a similar experience. Is everybody with me? Well, I'll demo the Jupyter Notebook in a second. So, and then one other thing to note is if you want to use Jupyter, you have to do Conda install Jupyter. Remember I showed you that command? Into each environment. It's not like, so one of the things that was really weird for me when I first started using Python, again, like 6, 7 years ago, with the Conda distribution, because I wrote Python a long time ago, when it was cool back then, and then it wasn't cool anymore, and then it's now cool, and so it became cool again, and then everybody had to use Anaconda. I think what was confusing for me was like, back 20 years ago when you wrote code, you got one IDE, and you ran the IDE, and there was one environment, and everything was in it. Now with all these multiple environments, you actually have multiple things that have to run. So like if you need Jupyter in one environment, you have to install Jupyter in that environment. And if you want to run Jupyter into another environment that you set up on Conda, you have to install Jupyter in that environment. And they're two separate Jupyters. And you'll see this in a second. But one other thing to note is once you install that Jupyter in the Conda environment, it will put a shortcut, if you're on Windows, to launch that Jupyter Notebook in the Windows Start menu. Or if you just activate your, if you open up Conda and do that Conda activate and you put your environment that you want to activate, you can type Jupyter Notebook and it will launch it as well at the command line. Yes, sir. So it will create multiple. So if you notice right there where it says Python 3.6 there at the end, that's the Python. That doesn't mean the version of Python. That's the name I gave that environment. And you'll see one that'll say, like I noticed if I install Jupyter, and like I'll do it real quick just so we can see. I'll let that run in the background because I don't think I have multiple installed. So I'll just do like Jupyter right here. We'll see if I can spell Jupyter correctly. It's not spelled like the planet. So we'll let that run in the background. Hopefully it'll run really quick. But you'll see a shortcut for each one. And the way you know which Jupyter you want to run in, if you want to do it from the command line, is you do that Conda activate the name of the environment. That sets all the environment variables up for that Conda environment. And then when you type Jupyter Notebook, it launches that. So let me demo this real quick, and then we'll go in the language. Actually, I'll tell you about it. I'm not going to demo it now, because when I go in and show you the language and demo the language, I'll be demoing the tools. So we'll do that then. Is that okay? Everybody with me okay? All right, cool. So now let's get to actual Python. So now we have an environment. We can have IDEs to write code in. We have environments that have the correct Python version and the packages that we need. Now we need to write Python code. Well, let me start you out. Real simple. We'll walk through all the basics in the slides. I'll show you some demos, and I'll show you how it works in Microsoft. So I think I got 30 minutes, so we should be good. Comments. A single pound sign to comment one line. Multiple lines, you put 3 little ticks, put the comments between it, you have multiple line comments. Everybody with me? Real simple. numbers, plus, minus, star, slash, addition, subtraction, multiplication, division. Here's some demo. I'll demo this code in a second, but you can see how we're creating a variable called tax rate. We're saying it's 8.25 divided by 100, so it makes it 0.0825. For next year, when you go to Houston's, to Pass Summit in Houston, that will be your tax rate, because that's the tax rate for City of Houston last time I checked. So you can take this code with you and run it and check how much your stuff's going to be with tax. That'd be really funny if one of you did that. And then, now we got the tax, the price, and then I got some print things to print out what it looks like, and I did some formatting to format it so it's pretty, and you see dollar signs. Everybody with me? This looks like code, these equal signs. The R lady, not a less than minus, although equal works in R now. So, a little R joke. Our people have to stick with our R jokes. Everybody with me? Single quotes, double quotes, they work the same. Right? So if you're doing strings, you can use a single quotes, double quotes, they work the same. The only difference is if you put a double quote on a string that has a single quote in it, it'll work. So, whereas you don't have to escape it. All right? Yes, sir.
So if you can go back to the previous slide, if you don't have the same column as a delimiter between each line, it knows that each line needs to start from the CRL, from the new line.
Okay, so this question we'll talk about later, just because we're going to talk about indentation. There's questions around like indentation, how it looks. That's because you've seen Python before. We'll talk about indentation in a second. Right now, everything's on the same line. So we'll get to his question in a minute. I'm going to hold questions to the end from now, just because if I don't, I have like 30 minutes. And I really want to spend about 15 minutes on this, so I can have 15 minutes to talk a little about how it works in SQL, in Microsoft, because I think that's important where you can use it. So makes sense, right? Got a variable, setting some things, doing some math. Simple strings, so you have single quotes, double quotes, works the same, right? If you do need to escape and you're in a single quote, use a backslash, right? If you want to span string littles, like if you want to create like a usage statement, do 3 triple quotes, and you can span it, and then it'll print it out with that nice format, just like how it sits. That's what those 3 triple quotes do. If you want to repeat strings, you can do that. I've never used any of these, but I want to start you with the basics, so if you do see it, you know what it looks like, right? So you can see how I did 3 times da, it'll put da-da-da, and you can put the ESPN song in your head, and that's how you do that. So this is important. Slicing and indices of strings. So positive things start with 0, but notice at the end here I have this 16. There's 15 characters, counting spaces, but I have this 16, and that's because when you slice a string in Python, whatever that last number is, it's not inclusive. So if I slice to 15, I wouldn't get 9. I would get to 210, because that's where 15 is right there. Well, actually, 15 is at 9. But since 15 is not inclusive when you do slicing, if I'd slice all the way to 15, I would get to 20. I'd get past Summit 201. So you have to, if you want to include that, and you're doing a slicing from like 0 to whatever, and you want to get that whole string, you have to say 0 through 16. This is just kind of to show you how it works. And then if you want to slice from backwards, it starts at -1 there all the way to -16, because it can't start with 0. 0 knows that you're starting to go left to right. If you want to do reverse slicing, that way. Make sense? And we have demos to show that slicing, but that's in the demo. Strings are immutable, meaning you can't change them. So you just have to create a new variable. You can't just update them. So length will return the length of the string. Make len. Everybody with me so far? So we'll do the demos at the end. So that's just the basics. Create some strings, some variables, do some math, right? Now we're going to go into some of the data types. So lists. Lists are kind of the most common ones you'll see. You use brackets. So I'm going to create a list. It's going to have a bracket, and there's 4 items in there. 1, 2, 3, 4. You use commas to separate them, and now I have a list of items. And I can slice and dice and pull those lists out. So I can slice and pull the first. Notice it starts with 0. R starts with 1, right? Python starts with 0 like the rest of the languages. So 0 is going to pull that first one. 0 is the first number, so 1 will pull 0. -3 through negative, it's going to pull that way, right, from 3 to 1. And then we can concatenate lists. So I can create a list. If I want to concatenate another list into it, I can concatenate them together like that. So that's not like adding 1, 2, 3, 4. It's not like adding 5, 6, 7, 9 to that. That way it's not like a matrix type thing. I'm just creating a list now that has 8 items. Everybody with me? Lists are mutable, so you can change them. So now that I have that list of 8 items, if I want to change the the last item to an 8, because if you notice, I misput that as 9. I can do that, and I can say, hey, change it to 8. So if you know what immutable means I can change it, immutable means I can't. That's just the simple way. I can append to it, so I can call a function. So Python's, it's an object-based language, so you can do functions. You can call the object dot some function. So if I want to add 9 to it now, so now I have 9 items, I can do that. If I want to replace a slice of it, so I can slice out a part of that list, and it doesn't have to be, I can say, hey, slice out these 2, and I can insert back in 3. Or I can slice out these 3 and insert in 2. You can do that as well. And if you need to get the length of the list, you do len, pass in that list object you created. Everybody with me? Tuples. So tuples are just comma-separated values. They can be nested, and they're immutable. So this is, I think the way tuples come in from lists, I think this Java's a really old language. My guess is memory is very expensive back then. To be able to make things mutable, to change and append and do all that, you have to use extra bytes and different things to be able to do that, and it's expensive. If you say, hey, you can't do that, and you can create a data type that's not mutable, meaning you can't change it, you can create, that's why I think that my guess is that's why they created tuples. They're used still in the language, because you'll see where things are returned, because it knows, hey, it's only 2 items, so I know I only need 2 items, I'll return as a tuple for performance. But that's the difference between a list and a kind of a tuple at a high level. So like if I try to change my tuple, I can't change it. So we got lists, we got tuples, and then we have dictionaries. So dictionaries are key value pairs. So I have a key, and then I have the value. So I have my name, the year I was born, wife, the year they're born, a friend, the year she was born, and my sister, the year she was born. Don't get too attached to my sister. She dies in a later demo. So right there, the next part, I just deleted her from the dictionary. So you see, my sister is no longer in the dictionary, right? So you have a key. I can say, hey, delete this key, Robin. That's the key. Her value is the year. So no, Robin's dead. If she ever saw this demo, she'd kill me, because she's my baby sister, and I'm like her hero. I'm her hero. My middle sister would be pissed, and she'd beat me up, because she's like this tall and like super athlete. So I had to pick the one that can't beat me up. So. So we can delete a value from a dictionary, right? So we have these key value pairs. We can list the keys. So this is listing them in order, or you can just sort them if you want to list them and sort them. So these are really cool. I use dictionaries all the time, because your actual value doesn't have to be like a string or a number. It can actually be a list, And so you have ways to pull and calculate things like that. So we have ways where you can take a dictionary to create we'll talk about it in a second, a pandas data frame, things like that. So pandas. So we have lists, we have tuples, we have dictionaries, we have panda data frames. And so pandas is a library install called pandas, and it gives us these data frames in series. And so it just gives us these labeled data array structures, like a table, right? It also gives us input-output tools. So you can use ODBC, you can do CSV files, Excel, ways to bring data into Python. There's a little 10-minute link if you want to get a quick demo of pandas, or come back tomorrow. We'll do more pandas, but here's some examples, right? So I got pandas. I can see where the formatting, when they made my PDF, it converted these to capitals. Those aren't capitals. No, I'm sorry, that's the title. Okay, sorry. So here's the import statement. I'm importing the package. I'm aliasing as PD, and then I'm reading the CSV file, printing the head of that file, printing the bottom of that file, right? Describing what it looks like, so I get some statistics and distributions. I can sort it by a column. I can select one column out with these double brackets, so I can select the teams out. I can group them, so I can group by the team and get the mean, and then I can print those sorted values by attendance, and you can see now where I can see the Royals really sucked, whatever year this was. I forget the year of this data that I pulled, but obviously the Royals were probably not good that year because their attendance was the lowest. So you can see we have a Panda data frame that we can deal with. And this is kind of pandas are kind of the main structure that we start using when we start doing data science, right? We bring in data as a Panda data frame, and we work on it. Now, I'm not talking Databricks yet. I'm not talking deep learning where we get into NumPy arrays. Come back tomorrow. We'll talk about NumPy a little more. But when you first start getting out and learning and building your first models, and you got the small data sets you get from Kaggle, you're going to import them as a Panda data frame. You're going to go to build your scikit-learn package and then start building your models and seeing what they look like. But pandas is kind of the foundation to get your data in. Is everybody with me? Anything like a table, right? A pandas data frame. So control flow. So his question earlier is about when he showed all the lines, they weren't indented. On Python, it doesn't use little squiggly brackets like C# and Java to do the blocks. It uses indentation. And it's like spaces. It's not tabs. So tabs are evil in Python world. And so what happens is when you have the internet and you copy some code in and you drop it in your IDE to use that code, it's going to change your spaces to tabs, and it's going to give you this indentation error. In Python, it does the structures with spaces. And I'll show you this in a second when I show you more data examples. But when you have a for loop and you say for this and this, you put a colon, and then you hit enter, and you go over 4 spaces, because anything more is crazy, and anything less is just as crazy. No, it's whatever you like. I do 4. But you go over 4 spaces, and that's the end of your for loop. And then when you're done with your for loop, you just go back 4 more spaces to the start of the line. And that's how Python works. I do not know why the person who wrote Python did that. He's retiring, I think, is what I heard last week from writing Python, if I remember right. But turn off tabs in your IDEs. Most of your IDEs nowadays will just have it turned off anyway. And just be careful when you're copying code from the internet. It will change your spaces to tabs, and then your code will get indentation errors when you run it, and then you'll spend all your time fixing those tabs to spaces. So just some conditional operators, kind of what you see. Like if I'm doing equal, greater than, not equal, this is what they look like your normal kind of language, right? So if then else, notice the indentation, right? So I have my, back up, not in my thing right here. Notice I have a variable called n equal 5, m equals 10. We're just going to print if these are single-digit numbers. So I have an if statement, see the colon? That's the end of that if statement, and notice the spaces. That's just, in this case, 4 spaces. I print. When I get to the elif, I go back to the start of the line, see the colon. You see how that structure works? That's how Python works. You don't have braces, squiggly bracket braces things, whatever those are called, like C# or Java or R. We live it crazy in Python world. Spaces and tabs drive us crazy. So everybody with me? But it's a simple if then else. Here's a if 2 is in a list. So you have that in statement that's really kind of popular. So if this is in this list, I found it, else print, right? Everybody with me? For loops. For I in a list, print I. So this is going to loop through and do that. I'm just giving you some examples of how these things look. Then you can go back and start writing your code. There's a word list. Python has a real cool, it's cute too, cool shortcut where I can just say for some variable in a list, do something. So Robin's alive again. Yay, we didn't kill her. She made it back in the family. So there's my family members. So Stephanie's the middle sister. And as you can see, my parents cannot spell our names the normally way. I-E, J-M-E-I-E, or R-O-B-I-N, or S-T-E-F-P-H-A-N-I-A. We had to have weird spellings because we had to be different. And that's probably why I have pink and purple hair. But everybody good? We see how we can loop through that list. Range, so I can create a range of numbers, 1, 2, 3, 4, 5, print that range, then loop through that range, right? And then loop over 2 more lists. This is really cool, this zip function. So I can have 2 lists. And so instead of having to write 2 for loops to go through both those lists and loop through them, I can do this cool zip function that says, hey, take these 2 lists. Q is the first, doesn't work when I move. Q gets assigned to this one. A gets assigned to this one. And so then I can just call 0, 1, call this format QA, and it's going to extract it, and then I can get, what is your name? It is Jamey, right? What is your occupation? So it's going to loop through those lists and do that. Does that make sense? That zip function is really cool. We do this a lot. It's a really cool feature. And then here's the same thing. We killed Robin again. So here's this, how I can use this KV thing and this sorter from the dictionary. So I can pull the key values out of the dictionary and report them that way. Everybody with me? Kind of cool? And then we have control flows, continues, breaks, and else's, just like you do in other languages. Just more on that. So just to show you that it's there, right? And then while loops. So while num is less than 10, we can increment it and go up, right? I'm just trying to get you the syntax, right? The idea is the introduction. I want you to introduce you to the language. And then simple functions, right? So we can have functions in our language to call things. So here's a function called greet summit. It takes a variable year, and then it takes another variable name. Notice how the first variable doesn't have a default for it. The second one does. If you have it that way, all the non-default parameters have to be first, and then the ones that have defaults have to be after them. So in this case, it's saying if you don't pass me a name, set it to none or like null, right? And then so I look if the name is null. If the name is not null, hey, welcome to Pass Summit, the year you gave me and your name. And then else print, welcome to Pass Summit, right? And then I call that function down there. So I'm just trying to get you the basics, if, then, else, while, how to build a function, how math and addition and comments and all that work. And what did I start with? What's the first thing I showed you? No, in the language itself. In the language itself. What was the first thing I showed you? Comments, yeah, right? Because those are important, because none of you will use them. No, I'm joking. Or you will use them sparingly. I'm joking. But please comment your code, because somebody will have to invariably go after you and read it, and it's usually me. So, but yeah, showed you that one first, because that's the most important one. No, all right. We'll move on from that. Okay, so let me show you real quick the demo, and then it gives me like 10 minutes to, because I think we end in 15, right? So goes back to the Jupyter question. Remember I installed Jupyter down in here, and it says it's there now. If I go back to my start menu here, and I go to my Anaconda, you can see I now have, actually I did have Jupyter installed other ones, see? Notice this Jupyter Notebook's in the base, because there's no name after it. That tells me it's in that base environment. Don't use that one. Leave base as it is. That's what, when you create your new environments, that's what it's pulling from to create them. And then you got my Python, my Summit. So what I did is I just clicked Python or TensorFlow, one of these. I clicked it, and when I clicked it, it started up a command prompt somewhere around here. I don't know where it went. There's a command prompt around here somewhere that's running this Jupyter Notebook. Actually, I think it's right here. So this is it right here. So when I clicked this Jupyter Notebook, it started this command prompt. And all it did was start the web server. And so you can see right here that it says Control-C to stop it, or you can just close the browser. So as long as you keep this running, now I have this web service running to run my Jupyter Notebooks. And so what I've done is I've went and it'll open up the Jupyter Notebooks, and it'll look like this. And then you can just go in and browse to whatever folder you want. So I can click up here. I can click right here. And if you notice right here, I have this IPYNB file. This is out on the GitHub. This is the Jupyter Notebooks for the demos. I'm just going to show you a couple of things real quick. So once I clicked that, it opened it up in a separate tab. If I double-click this, this is a code markdown language. Looks like Java. I mean, it looks like HTML. You have this pound. This pound makes it a H1. And all I had to do, and then if I hit Shift-Enter will run each block at a time in the Jupyter Notebooks. And all I have to do to create these cells is I can say, insert cell above or below. And then once I have a cell, I can use this drop down to say, is it a code cell or a markdown cell? Everybody with me? So this is a markdown cell, see right there. Then I got another markdown cell. And if you remember, these are just the demos you saw me have in the slide deck, right? So if I hit Shift-Enter, it's going to run this demo to show you what a comment looks like. And notice how it puts the output here. So I'm just going to kind of run through these real quick. You saw this demo earlier. It runs it. Notice it puts the output right here. If I go to the string, here's the example of strings. Here's where I'm slicing. So here's just some examples. I won't walk through these because you can kind of run them on your own. But you can see where I'm just doing different things of slicing. Notice, like I said, you can't change it. So if I run this, then you can see where it's sliced and diced certain parts of the string, right? Here's some list examples where I can do list. Here's tuples, where I'm creating different tuples and changing different things. Here's dictionaries. Bye, Robin. We killed you. Right? So these are just examples. I mean, I showed you these slides. Now here's Pandas. So this is kind of cool. Here's what Pandas did. So I read in this baseball CSV file. I had said, hey, what type is it? And I didn't print the type, so that's why I didn't show it. But if I say print type right here, and if I hit Control-S, I saved it. So you can see right here. If you need to create, I forgot to show you this. If you need to create a new notebook, you can just say new right here and just say notebook Python 3. So now if I run this frame again, you can see right here where when I did that pandas read data, the type that came in as a panda data frame, right? And then just did some grouping, some sorting, and print the means. Notice when I did the describe right here, you get some output far as like statistics, like the mean, the the quartiles and whatnot. Control flows, I'll just run through these real quick. This one's kind of cool. It's saying, hey, let's give me an integer. So you can see while true. So I'm just looping through until you give me something true. So if I say A, hey, that's not an integer. If I give it 4, hey, you gave me an integer. Simple functions, I showed you these. So this is just a simple function. Notice the indentions, right? That's how we know this is the function. The function's done right here because I'm back to the space. Actually, it's technically right here. Make sense? We see how the indentation works? They always end with this colon, and then we have that. And in this case, we have a variable called m. Packages. So this %matplotlib inline, I'm using this in Jupyter Notebooks. You won't have to put this in your Visual Studio Code. But what this says is, hey, I'm going to output a visual, and I want to see that inline in the code. And in this case, I'm showing you how to connect a SQL Server, query that same baseball data set that I just imported the CSV file to a table, and then I'm going to show you this plot. And so when I run this code, it's going to connect to the database. It's going to run the code. So in the examples, what I want to show you here is you have examples to run, like just how to connect to a database and get code, right? And so finally, let me go. So it's very clear there. That's the Jupyter Notebooks. You can have markdown cells. You can have code cells. And we can walk through these and use this way. I also have a Python version of it. So everything I just showed you is just in a Python file. They usually end with .py. And we can walk through all those as well. But just to kind of real quick, to show you why I like Visual Studio Code, some of the things you need to do is in the extensions here, look for Python and install the one that says Microsoft. Right here, see? Not all the other ones that have other people's names. Here it says Microsoft right there. And then go Anaconda and see where it says Microsoft. Install these 2 extensions. When you click on them, you can install them. Mine are already installed. And that's going to then give you this interactive environment. One thing you need to note is you need to install Pylint and you need to install Jupyter. In any environment, you want to use Visual Studio Code to get this interactive environment. One thing to note down here, this is in the environment. This is showing me this is showing me the environment I'm using. This is a Conda environment I call TensorFlow. I'm picking that. And then if I want to run these, I just highlight it and then hit Shift, and I can say run selection line in Python interactive window. See that down there? And then what that's going to do is run that over here. And what's cool is you see these blocks here. I can click this little thing right here, and any kind of variables or objects I create in my code, they're going to show up there what they look like. And then I also can run it and say, hey, I ran this and say I want this to go away. I can click this little X and it can go away. So let me just create a variable real quick so you can see. So if I run this, you can see now all these variables I create show up here. If I go to the Panda data frame one real quick, let me create the Panda data frame one. If I run this and create the Panda data frame, Shift Enter, this is going to read the data in. And you notice now it's got baseball, it tells me its data frame type, and then I have this cool thing over here on the end. That's this little thing. If I want to see that data, I can click this, and it's going to open that data over here on the left where I can see that data frame, right? So I can see what data I have. So it's really good. So when you're like, why is my code not working? Like, why am I getting the model out? And you go look at your data frame, and you go, oh, wait, I have no records in it. Or like, this is not the right data, or the columns are different. So we can see that. So this is how I use Visual Studio Code. So I'm just going to go back to the slide deck real quick. So everybody good? You see how the language works? These are all on the GitHub. You can do these demos. So let me walk you through where you can use Python in Microsoft, because we have about 6, 7, 8 minutes. SQL Server. So SQL Server 2017 and higher. You can use this SP execute external script and use it there. I have a demo of that for you. So when you go, oh, I apologize. I didn't download it. I accidentally closed that window. While that's going up, we'll go right here. Sorry. So we'll go back to that. I'll show that real quick. But we can run Python code inside a SQL Server, so to speak. So what it's doing is there's a thing called a Launchpad service. You run this SP execute external script, and it's going to execute the Python code that you have in that store procedure, and it uses this Launchpad service to call the Python environment that's installed on your SQL Server, and it takes the data and sends it as a data frame over into and runs it in the Python, and it does this back and forth, and so you can run this Python code in SQL Server. And you can also do cool things like when you build a model, and this is coming in 2019, you can store it out as like an Onyx model, and then you can actually just predict. So you can just have your data in there, and that can call that prediction of that Onyx model you built in Python to predict against it in like real time. So they also have some Revo scale libraries. So Microsoft purchased a company to kind of make R faster, this company does, but then they also did some fun things with Python libraries that run inside of this SQL Server that can run a little faster. But the point here is we can use this XP external script to run SQL Server. I have code for that. Azure Machine Learning, it's a GUI web-based thing, so I can develop models through a GUI in Azure. It has a Python way to run Python code. Azure App Services, come back tomorrow. We'll build a full model, save it out as a pickle file, which is just a way to store to a binary file your model. And then we're going to deploy a Flask container, which is just a way to do a REST service. We'll deploy that model as a Flask service to Azure App Service so that we can then call it from any code that can call REST services, do our prediction. So the idea being is we build a model, we have this good model, we save it out, we deploy it to the app services, and now we can build REST services against that to call it in our code. Azure Functions, so these are serverless type functions. You have the ability in Azure to take your Python code now, I think it's as of a couple months ago, or July maybe, you can actually use Azure Functions, which are not quite the same as app services. They're a little more lighter weight, and you can deploy your Python code now into Azure Functions to work kind of similar as REST services. Databricks. So Databricks is super high-scaled clustering Spark. It's based off of Spark. Databricks is the company that built Apache Spark, which is a super high-speed clustering environment to do machine learning and data analysis. You can run Python in Databricks, and it'll use these Databricks notebooks, and they look kind of like this in the browser. So this is just kind of giving you a tour of what it looks. This is like a whole other session. It's actually going on right now if you want to learn Databricks. But we can run Python there. And then Power BI. I mean, do it in two ways. One, we can show visuals. So that's what this is right here. So I can create a Python visual and have Python code that shows a visual. Or on the get data experience in Power BI, I can actually have Python code that runs to get my data. And what it does is that Python code returns a data frame. You have it return a data frame, and that data frame becomes a table in Power BI. So let me demo. I have a demo for Power BI and SQL Server, and then I'll have maybe like a minute or two for some questions. But before I do that, let's just do this. Here's some references. Do these session evals. That's how you can find me. I'm going to close the slides out, show you some demos. So in Power BI, if you look right here, if I did edit queries, I created a script here. And if I just go and look at the advanced editor here, you can see where this is the source. And this is where this Python code is right here. But if I also come over here and I look at the source right here, you can see this is the Python code that was executed. In this case, I'm just saying read this CSV file. And what this does is then returns this as a data frame here. And then once I have that, I can then come in here, drop a Python visual over here, which by just dragging this here, and then I can write code here. In this case, I'm saying show this correlation plot. So this is how you can run Python in Power BI. One thing you have to do real quick is go to Options and make sure in your options you set up what environment you want to use right there. Everybody see that? And I got 1 minute left, and let's do this real quick. Let's go to database. I have a database called Intro to Python. I say new query. Actually, say recent file, so you can see I still had it there. And I have this file out there. One thing you're going to need to do as well, if you haven't used this, you have to run this command. So you have to install the machine learning services. Make sure you pick Python 2017 or higher. And then in your database, run this command to enable external scripts. And then once you enable them, then you can run these scripts. And what I'm doing here is creating a table of some data. Here I'm creating parameters, some things. And here's the external script. you see where the language is Python. Here's the Python code that's running, and then it runs that. And if I execute it, we all cross our fingers, and I had Python highlighted, and so that's what it did, is it just literally ran the command Python. It should all work. So this is all out there as a demo. So you have demos of how to work in Power BI. That Power BI file I show you can get off the GitHub. The SQL script I showed you, you can get that and run that in your SQL Server. All the Python code I showed you, Jupyter Notebooks, those are all out there, data sets. Come back tomorrow, we're going to put it all together real cool, build out a data model, save it out and store it, build a Flask app, publish it to Azure, and you'll see how all this really pieces together and how I can build an actual data model and an application in Python. And I can answer some questions. Thank you. Sorry.